So hi everyone, welcome to Raaonline. This is Dr. Stevenson, your faculty for biochemistry, and in today's session we will be seeing about post-translational modifications. In the previous session we have seen very exhaustively regarding the translations. Okay, translation in prokaryotes, what are the requirements of translation, translation in prokaryotes and translation in eukaryotes. Now in this session, what is the product of the translation after termination? The product of that translation is nothing but a polypeptide chain, a long polypeptide chain. This polypeptide chain is a non-functional protein. This has to undergo extensive post-translational modification in order for that to get converted into a functional protein. So this process is called as post-translational modification of proteins. Now we will see what are the various modes by which this kind of modification occurs. It is something like preparing some kind of a cast, some kind of a new, how to say, some kind of a metal toy or something like that. Okay, you prepare the crude one and you start polishing before you sending it to the sales, right? So similar to that, you get the crude one, you have got the crude polypeptide chain. That crude polypeptide chain has to be packaged, has to be done all the kind of like it has to be shined and it has to get packaged neatly so that it can be sold out. So these are called as post-translation modifications. So it is of two types. The first one is proteolysis. In this, the excess part will be cleaved. That is called as proteolysis. The second one is covalent modification. Covalent modification is that you have got the crude part, you attach some other part to that through covalent linkages. You paint it or you attach some other kind of a fancy thing on that so that it becomes more attractive now. So these are called as what? These are covalent modifications. Proteolysis is you are cutting the excess part to make it in a more crispier form. That is called as proteolysis. Now we will see each one of them in detail. So proteolysis, what is this? Proteolysis means you remove the initiator methionine. See, sometimes some kind of a protein does not require methionine. I told you all the translation starts from AUG. AUG codes for methionine. That does not mean all the protein has to have methionine as its starting amino acid. Are you clear with this term? Because it differs. Only for translation this AUG code is needed, methionine is needed. After that, methionine is not a mandatory thing to be seen in all the proteins in your body. So what it does, the methionine has to be cleaved from the N terminal. So this is carried out by proteolysis. Okay. Now the second one is activation of proproteins. So some of the proteins will be seen in an inactive form. They are called as zymogens. For example, pepsinogen, trypsinogen, proelastase, procarboxypeptidase. So these things are called as zymogens. These are in their inactive form. They can be activated by cleavage. Once they get activated, they become the active form. So the pepsinogen will get converted into pepsin, which is the active form. Trypsinogen will be converted into trypsin, which will be the active form of that enzyme. Okay. Proelastase will get converted into elastase. Procarboxypeptidase will get converted into peptidase, carboxypeptidase. So this thing is termed as activation of proteins. So it can trim the thing much further. Then the final one is cleavage of the signal peptide. See, you have got a polypeptide chain. This polypeptide chain is basically formed in the ribosome, and once that is formed, it enters into the Golgi bodies, where inside the Golgi bodies it gets packed, it gets sorted. It gets sorted according to the signal peptides which are seen on the end. These are signal peptides.